So welcome everybody to new event from Cloud Native Asturias. This is the March event. Thank you everybody. My name is Marcos Lobo and I'm here with Angel Suarez. Angel, how are you doing?
Hello everybody. Very, very well, thanks. I'm very good, Marcos. Thank you very much.
Great. I don't know if you take the opportunity to see I'm pretty sure you did, to take a look to the agenda that we have today. I'm really excited about the presentation that we have today.
Yeah, we have a really good speakers. So yeah, let's get on to it.
Let's do it. So of course, maybe you know, this is Cloud Native Asturias. This is an official community group from Cloud Native and Computer Foundation. Okay, so this is our motto, let's say. This is the mission that we are sharing. For all the events where we are going, we have this official code of conduct, the official one from the CNCF community. Nothing special, okay? Just be nice with the people, respectful, and everything will work like a charm. Nothing special. Also, in this occasion, we wanted to, let's say, put in the map Asturias. You know, Cloud Native, these kind of community groups are meant for a region. And we realized that we never did this exercise before. So in this case, we wanted to share with you, for example, let's imagine that someone from Austria, what a coincidence, could want to our region. Okay, in this case, unfortunately, we don't have direct flight. So you can see here in the screen, maybe it's a bit smaller. It's like 9 hours. I can tell you that you can get your plane from Vienna, reach Madrid, and from Madrid, you can take another plane to our region. It's not ideal, but hopefully in the future we'll get better with that. Also, let's imagine that you want to come from London. In this occasion, we are very lucky because we have direct flight from London. I think I don't remember the airport. I think it's Chadwick, maybe. Not sure about that.
I think it's Gatwick.
Gatwick, there you are.
Yep.
Exactly. So in 2 hours, only 2 hours, you can come to our region. This is amazing. Hopefully you enjoy this. It's just to put the dots in the map, let's say. Okay. During the whole event, okay, you can share in social. These are the tags that we will use during the whole event. We'll share screenshots, comments, and so on. Please follow there. This is the agenda. Okay, we will start with putting cows into continuous delivery. This is really, really cool presentation, I can tell you. And the last one is from on-premise to software as a service system, a journey to the cloud. Okay, again, very interested. I'm pretty sure many of us we are crossing this path. And for each of the presentations, for putting cows into continuous delivery, we have a pleasure. It's our pleasure to have Jürgen, which is the maintainer of the Captain project. Very interesting project, people. If you didn't check it out, please check it out. It's really, really interesting project. And he's Jürgen, and he's working nowadays on the Dynatrace. He will introduce himself later for sure. And for the second presentation, we have Andrés. Andrés is a technical architect today working in Backbase, and you can reach him in Twitter as well in that name. So I think I would say no. Before I start talking, you have the chat in the right side of your screen. Okay, please remember you have the Q&A section. So you have any question, please put it in the Q&A. If you want to put it in the chat, that's okay. We will gather all the questions and we will make it to the people just when the presentation is finishing. And now I think, yes, call for papers in case you want to be a presenter in some of the monthly events that we will have in the future. Please just scan this QR code or go to that link. Follow the information and you will have the opportunity. That's it from my side. So let's go to the interesting part, which is we will start with Jürgen. I'll stop sharing my screen. Jürgen, the stage is yours.
Cool. Thank you so much. Let me share my screen and I will be, we have, so I will be moving over to my slides. And thanks for the warm welcome, and also thanks for the nice introduction. Yeah, I'm really excited to be here today and talk a little bit about a very new topic that we have kind of integrated, or that we are working also now within the Captain project. And it's actually a talk that I will be giving at KubeCon, and this is kind of let's say one of the first iterations of this talk. So there will be more to come, but I'm happy to already share something with you today, and also get your feedback on this. So getting this from the Cloud Native community is really, really helpful also for me. So please make use of the chat. I won't see it during my presentation because I full screen my slides, but after the presentation, I'm happy to chat and to talk about this. Actually, we had the same idea to kind of put in the distances right now with all this working from home. It's a pleasure for me, and it's easy for me to join at this meetup group. And I'm from Linz. This is in Austria, and going there by car would take me a full day. We just saw coming here by plane is also quite a journey. But joining from my home office is really easy, and it's a pleasure to be here. So thanks for having me. And yeah, I work at a company called Dynatrace. It's a software intelligence solution coming from the APM space, from application performance monitoring. And now this product can do way more. This is where I work at. This is the company I'm working for. But most of my time I actually spent on a project called Captain. It's a CNCF sandbox project. I think we started it around 2 years ago now at Dynatrace. So it's influenced kind of by Dynatrace, but it's now a CNCF project. You can check it out here. Code is obviously on GitHub. You will find it also from the website. And inside the Captain project, I was one of the first contributors and also core contributors to the project, but I've now moved more into the part where I take care about the community and the ecosystem of Captain, how we integrate with other tools, and this is how all the chaos engineering and this background came into this, and how basically I developed the story and the integrations, what I will be talking today, what I'll be talking about today. And yeah, I'm also a co-organizer of a meetup group. So we have a similar meetup group that you have here. We also have it in my hometown. You're all most welcome to join. Next one is on, I think, next Tuesday. We're running the next one. It's focused a little bit on cloud security. But yeah, anyway, if you ever want to join, you're most welcome. And on Twitter, here is my handle if you also want to follow me there. But actually, let's jump into the topic to discover how we can evaluate the resilience of applications with chaos and with service level objectives. These are the two main parts that I want to talk about today. And the reason that applications fail, they are kind of, some of them might be really obvious, because applications fail because we as developers, we make some mistakes. They should be discovered during the testing phase, but sometimes they are not, because they happen in very, very rare cases. So there might be errors in my application, but there might also be some outages of third-party services, third-party components. I cannot really influence this. I can influence this by kind of having some code in my application logic that can basically treat these outages correctly, but sometimes it's just you cannot really do anything against this, or even worse, if it's infrastructure outages, it's very difficult to kind of tackle or to overcome infrastructure outages. Even though you can go to the public cloud and you would assume it's running 100% all of the time, 24/7, but it's not always the case. So I think we as developers and everyone that runs software, we just have to accept that applications fail, services fail, and we just have to find a way to live with this. SLOs, for example, are a great concept to measure this and kind of also to accept a little bit of failures. But also how to evaluate and find a way to improve resilience is also a very important part. So instead of, actually, when I got first introduced to chaos engineering, it was kind of something like testing in production. We kill something in production, we delete some parts in production, we remove a hard disk in production, and we kind of have our hypothesis that it will work or will not work anymore. But we are doing it in a kind of risky way to see what is actually the impact for our end users, because that is really our main goal, to see if our end users, if our users, our customers are impacted and how they are impacted. So we can, of course, move it to a pre-production stage, move it into a dev stage, and do ad hoc experiments. But actually what I want to advocate is you should shift left, but doing this shift left in a continuous way, putting chaos as part of your CI/CD pipeline. Do the chaos evaluation each time, treat it such as a performance test or a load test or whatever test you do already execute and that you already have in your organizations. Treat this as some kind of necessity you have to do and you have to evaluate. And with this, there shouldn't be any kind of human interaction to trigger the chaos, but it should be fully included in your pipelines. So I'm not the maintainer of the chaos engineering part. So the chaos engineering, there are great folks that can tell you everything about chaos engineering, but I'm working on the Captain project, and I will show you how you can integrate it in CI/CD pipelines and how you can use it from a, let's say, user point of view from chaos engineering, not from a chaos engineering expert point of view. So if we want to evaluate and improve the resilience of our applications, we usually test them, and we have some performance tests, we have some load tests, we have stress tests, but I would argue this is not enough, because we really have to make sure to also evaluate the fact or evaluate the circumstances if our application is not responsible anymore, if our application, if some parts, some instances of our application just got deleted, if the network is going down, if the CPU usage goes up to 100%, if my disk is full and I cannot write anymore to my disk. So these are also some things you have to consider, and these are important to also evaluate as part of my, let's say, testing phase. So I think we have to establish a process to put chaos also into CI/CD pipelines, and then to also evaluate the resilience using a couple of different metrics. You can get them from Prometheus, for example, or as I said earlier, I work for Dynatrace. You can also get this from Dynatrace, but also a lot of other tools out there that can provide you values, can provide you insights. And you can use service level objectives to not only look at the metrics, but to actually build a, let's say, holistic overview of your microservice quality, and then evaluate based on service level objectives. And then iteration over iteration, you can go ahead and improve the resilience of your application by taking a look at the results. And you can even use this result and this evaluation as a quality gate mechanism in your CI/CD pipelines. That was actually one of our first ideas when we built this integration together with the folks from Litmus, to have an integration with chaos where we can evaluate the resilience of an application and prevent it from moving from a pre-production stage to production if it is not resilient, if it does not satisfy our resilience criteria. So what do we need to build it? We need some kind of chaos engine that is ready to execute the chaos. We need the orchestrator to trigger the chaos, and we need the evaluation part. And I've already spoiled that which software we are going to use. You can guess it. But it's important that you first, when you start to kind of make sure what do you want to have, do you want to build it everything by yourself? Do you want to have it integrations out of the box? Are you using cloud native technologies? Do you want to have it declarative, based on Git, scalable? What are your requirements? And based on our requirements here, we've chosen Litmus, for example. There might be others. I put a couple of those here, but Litmus is one way to do it in a very cloud native way, and in a, let's say, Kubernetes native way. So everything is basically YAML configuration. and you apply these YAMLs, and there is a chaos operator running then in your Kubernetes cluster, taking care of everything and basically executing and orchestrating the chaos for you. I have a little bit of background here, how Litmus is actually working, but I also have a demo prepared, and I think we see most of it also in the demo. And while the demo is executing, I will just explain a little bit. So I will skip this part here. For the second part that we kind of discussed for our requirements, we need some kind of orchestrator that starts our load test, that starts our chaos, and then starts our evaluation. And for this, I've chosen Captain, first because I'm a maintainer of this project, but also because this is actually what Captain was built for, to orchestrate your application lifecycle. So it's not a continuous delivery tool per se, it's more an orchestrator of continuous delivery. And it's not a testing tool, and it's not an auto-remediation tool. It can do all of these things, or it can trigger those tools that can do this best, but you can see Captain as the orchestrator for these different parts. And one part that is baked into Captain as a very central component is evaluations based on service level objectives. So we can see here a quality gate evaluation on this slide. It's basically each time you run a Captain workflow, Captain can make sure to evaluate the quality of your service. And the data is coming from a data provider. It can be Prometheus, it can be Dynatrace, it can be others. But what happens before, like which kind of tests have been executed, which kind of, if there's any chaos to be executed, if you do this, if you run this in production, this is just the way how you want to use Captain. So it's not just yet another CI/CD tool, but it's really built around the evaluation of service level objectives. And you can integrate your tools to Captain, and they will be then orchestrated by the platform. So it's built in the way that it lives as a control plane in your Kubernetes cluster. And it's not an operator. It basically receives and sends out cloud events. Cloud events is another CNCF project, and Captain uses cloud events to interact with other tools. And we have a lot of different integrations. For example, test integrations. We have a Chimida integration. Selenium is just in the works right now from our community members. We're just working right now with the folks from the Locust community to also do the Locust integration. And of course, we have this Litmus integration when we just talk about the test automation. For delivery or deployments, we have a Helm integration. You can also trigger Jenkins pipelines if you're still using Jenkins. You can have your Jenkins pipelines, for example, orchestrated by Captain to trigger the delivery with the Jenkins pipeline. But afterwards, you trigger, for example, a Chimida integration to execute the Chimida test, to not have everything in the Jenkins pipeline, because this is one of the things that we see a lot, that these pipelines grow and grow because you put more and more integrations into one pipeline. And this is a little bit different in Captain because you just have one file, basically around 20 lines of code that defines the whole CD pipeline. And then you integrate tools into it and not write it directly into the YAML. But you basically add the tool in terms of a listener of cloud events. We will see this in the demo anyway. So yeah, so in the declarative definition of Captain, we call it the shipyard. And I'm from Austria, we speak German, and for us, Captain sounds like the captain of a ship. So the shipyard would be basically the instruction how to build the ship. And we're coming up with all these terms. So basically the shipyard is a specification or a definition of an environment. So in this case, I have a couple of sequences for one stage. I just call it staging chaos, but it could be can have any name. And I define a delivery sequence. So in this sequence, I want a couple of different tasks to be executed, like the deployment, a test, and an evaluation, and then eventually a release if the evaluation is fine. I do not really specify which tool is responsible for the deployment, or which tool is responsible for the tests or for the evaluation. This is part of another concept in Captain. It's the Captain uniform. And in the uniform, you basically link the task with the tool that will pick up upon this task. So in my case, I have for testing, I can add JMeter, for example, and Locust, and let's say Litmus. And then they will pick up this information and they start the work. And when they are finished, they send back the result to Captain, and Captain can move on to the next stage. So if I want to change it from performance testing to chaos testing, I can easily change it just right here with one simple change, and I don't have to rewrite all my pipelines. I can even reuse the same pipeline for different services and for different projects. So usually one definition is for one project that holds multiple services. Like you can think of a project as the hipster shop would be a project, and all the different services that belong to the hipster shop are in the services. And this definition would be true for all the services in this project. So there's really a loose coupling between the tools and the task definitions. I have SLO-based quality gates baked in. I will just reveal this because I don't want to run out of time and still wanted to show you the demo. So the important part here is Captain has a distinction between service level indicators and service level objectives. First, service level indicators, we can think of this as a mapping between a name and let's say a PromQL. So we basically map the error rate to a PromQL, how to retrieve the error rate. And then, that's the important part, we can use this in a service level objective file. And here we can specify what is the objective, what is the goal our service has to satisfy. And I can build a large or not so large objective file, but just by writing just by using different criteria, either fixed thresholds or relative thresholds, for using this for my services. And then once you trigger a Captain quality gate, Captain, if it's triggered by Captain already, then Captain knows for which time frame it should evaluate. For example, Captain's orchestrating your whole testing. Captain knows when the tests have started and when they have ended. Captain knows for which services you have started the tests and ended the tests. So Captain will reach out to the data provider to fetch exactly the right data and then evaluate this. You can also just start the evaluation by yourself, for example, with the Captain CLI. And Captain will make sure to reach out to the data providers, query all the data via the indicators, and then scoring it based on the service level objective file and coming back to you with a final score. And based on the final score, you can then promote it to the next stage or roll it back, for example. And you can also define the total score when it's allowed to pass or when it has to be held or even rolled back. You can define it also with a threshold. So this is how the quality evaluation works. And I will now jump into a demo. And what we will see is I will deploy a sample application. I'm using here the potato head. It's a CNCF demo project. Now it actually has a new logo, but I'm still using here the old one. I will deploy it into a stage with Helm, all orchestrated by Captain. Then I will trigger some tests into my chaos stage, but not only load tests, but also litmus tests. And as I said earlier, right now we are building on an integration with Locust performance tests instead of JMeter. So actually for the demo, I'm not using JMeter, but I'm using Locust. I'm just experimenting with this new integration, and hopefully it will work for this demo. But you can think of it as JMeter tests or artillery tests or whatever testing framework you're using. And then when the tests are finished, Captain will automatically trigger the quality gate and evaluate the resilience of my application. And then based on this outcome, we can tweak it a little bit and can find out if we can somehow improve the application based on the quality gate evaluation. So this is what we're going to do. There is basically, I have a description here how this environment will look like, but we will anyway see it in the live demo, and I'm happy also to answer questions if there are more questions how this demo is set up. Basically, I've already showed this or explained it a little bit. So let me basically just open up my other, is it somewhere? My Captain's Bridge. So, okay, let me just start here. I do want to send a new event to Captain, and it's an event for deployment. So basically, this is the cloud event that I want to send to Captain. And for us, the important part is only which image and the replica count. Everything else basically is information for Captain, the project, the service, and the stage I'm deploying to. So this is the file I want to send to Captain. So I'm now triggering a deployment. So I'm doing a Captain send event. It has other option also, the CLI, but this is just fine for us. So what is now going on is it will trigger a deployment, and I just need to find real quick my other window. And it actually should be this one. Yeah. So yeah, this should be fine. So I've just triggered the deployment. Captain already tells me the deployment is finished. We can see it here. And it's now initiating the tests. And we can see 2 test integrations have been triggered. Litmus, hopefully you can see it and it's not too small. I can make it a little bit bigger. One is the Litmus service that has been started, and the other one is the Locust service that has been started. Both integrations are now picking up configuration from Captain. As said, it's Git-based, so all the configuration is in a Git repository and can be retrieved by the service integration. So they are basically picking up the instructions, which chaos experiment to execute and also which load test to execute. Both services are now starting and executing basically their work. What we will see, taking a look here, is actually there is a Hello Service chaos runner, there is a pod delete already coming up. So we can already see that a couple of things have been initiated already behind the scenes. We will do anyway another test round of this, so we will then see a little bit in more detail when the chaos has been initiated. The pod delete is already completed. So by the way, I'm using here Lens. It's a very nice IDE for Kubernetes, let's say, and we can just inspect what's really going on. So we can see 2 jobs have been actually completed, and we have 1 instance of my Hello service here running since a couple of seconds. So this was the one I was deploying, but it was actually also the one that got removed by this pod delete chaos experiment. So once the chaos experiment has completely finished, it will send back this information to Captain. Same is true for the integration with Locust. When the load testing is finished, it will send back the information to Captain. So Litmus is already finished. Locust usually takes 2 minutes. So I think in my tests for today, I've set it to 2 minutes. And then it should send back. Yeah, here we go. So Locust is also finished. This is just part because, as said, it's work in progress. So I still give a lot of debug information back. Both finished and both integrations finished with pass. So they basically did their job and they do not complain about anything that was happening. But what did not finish to my satisfaction was actually the evaluation. So I can take a look. And what I can see is that the probe duration and probe success. So I have 2 different goals, 2 different SLOs I want to meet, and both of them did not meet the criteria. So now I have something in my way. I move it here. So I can see it did not, both of them, they did not pass my defined quality. The probe duration, it took too long for the probe to respond, and the success percentage was below 95%. Actually, I would have also accepted 90% of success, but I only got 70% of success from all the probes that I did with my Prometheus. So what I kind of now evaluated, if there is any problem going on that a pod gets deleted, I could not satisfy my quality criteria. And a kind of obvious way to improve this is to just say, okay, I want to actually run it with a replica count of let's say 3. So I have 3 instances of the same application running, and hopefully Kubernetes will make sure that it distributes all the incoming requests to the pods that are actually running and responding. So let us go back to Captain and take a look here. It's my Litmus project. And let's take a look at the sequence screen. So this is the run I just started. The deployment is not yet finished, but this time we will take a look, a little bit closer look in Lens. So I can see deployment is not yet finished because 2 additional pods of this service are coming up. So Captain is actually now triggering Helm deployment with a replica count of 3 or a replica set of 3. Once these 2 instances are also coming up, this information is sent to Captain. Captain will move on with the next phase, which will be the testing. So right now it looks like this is up and running. It's not yet sent back to Captain, so the Helm service just maybe does another probe or something. But once, here we go, it's now finished, and tests are initiated. Both tests, again, Litmus and Locust. So let's take a look. The Litmus service is actually right now coming up, and we could see there was 1 pod killed. So there's 1 pod just starting right now. So it's 3 seconds ago, this new pod just started, and another one that was just created earlier with this deployment information got removed, basically. So there is 1 new pod coming up. It's not yet ready. It has a readiness probe of, I think, 30 seconds, something. So it will wait 30 seconds until it's able to retrieve some more traffic. Here we go. Now it's green. It's also now receiving traffic. So what's actually happened the first time was our only instance of this application got removed. Then it could, of course, not serve any traffic. Some probes from Prometheus failed because it could not serve the requests, and our quality gate evaluation failed. This time, I had 2 other instances up running. 1 instance, of course, got removed again, but actually the other 2 should be able to serve all these requests that were coming in. It's kind of an easy example, but if you think of this, having this integrated in some kind of CI/CD pipeline without having to rewrite the whole pipeline, this is possible with Captain, and you have all this integration of the quality evaluation already baked into the platform. This really is great to evaluate this in a very continuous way and blocking anything before moving into production. So we just wait here again for the other tests to finish. So they finished, and this time right now it's fetching the data from Prometheus. But once this is finished, actually I see a green icon and I can take a look, and it basically now finished because almost all of the requests got served, and also the duration was quite fast, so it responded quite fast. So this is basically how we are evaluating this, and I know it's only 2 different SLOs here, but it could be way more, and the experiment could be way more complex. I'm just doing this for also the purpose of the demo, that it's a very small experiment. It's only a pod delete experiment. I would say it's one of this kind of hello world of chaos engineering, but you can see hopefully the value that you can get out of this. Let's move back to my presentation. I think I don't have a lot of things left, and then I'm happy also to answer some questions or get into a discussion. Okay, yeah. So if you think this is something that you want to give a try, basically you can install Captain. You will install Captain via a CLI. You can get the CLI here. You will also get it from captain.sh. And the integration, basically, we just moved it to the latest version to be compatible with the latest version of Captain. You can find everything in the repository of the Litmus service itself. We also have just released yesterday a tutorial on how to basically walk through this use case that I just showed you. And what I've showed you is basically how we can define service level objectives and how we can use it, how to integrate this into a CV pipeline, and then how we enabled continuous evaluation based on these SLOs and SLIs. Everything that was stored in the Git repository, I've not showed you this in detail. If you're interested, we can also take a look at this. I would just want to, probably I will put it in the chat, the tutorial that we just finished yesterday, where you can also give it a try yourself if you're interested. But yeah, I'm happy to answer some questions. I will stop screen sharing so I can also see you. Yeah, thanks very much.
Thank you very much, Jürgen. This was an amazing talk. And again, I want to reemphasize the point of this, the sneak peek that Jürgen brings to us today from the future KubeCon and Cloud Native Foundation Con that is happening next month in May. Okay, so that is an important conference. Jürgen will be there. I just put the link over there just in case you are interested in his talk next May. And I see that people are a bit shy in terms of questions, so please don't hesitate to write them down. We have at least one actually from Andrés here.
I think we have actually three.
We have three.
On the main chat.
Very well.
So, yeah. So perhaps we can start with Andrés. What kind of experiments are included by default? Could we introduce custom ones based on our stacks or third-party software? It's a question directed to Jürgen.
Yeah, I think very, very good questions. So let me just basically, I will just do another screen sharing so I can show you how we integrated this experiment. So let me just share my screen again. And in this case, what I've done is that this is basically the Git repository that is running behind the demo. So we can see a couple of minutes ago, Captain did some commits on this. What I will show you is the litmus part. So in the locust part, we would have our load testing instructions. And in the litmus folder, we have our experiment.yaml. This is the experiment that we are executing. For Captain, it doesn't really, it's not important that Captain knows which experiment. For Captain, it's just important that it has the instructions somewhere. And it basically does a kubectl apply of this file. That's basically what this integration does. So it's applying this integration. And here we have a pod delete. This was just the one we have went with to kickstart this integration and to also do our demos with. If you're interested in all the different experiments that come with Litmus, actually there is a hub from Litmus, and you will find a lot of different experiments that they have, like the pod delete, CPU hog, container kill, whatever. So you will find a huge variety of different chaos experiments. For Captain to be able to execute them, you would basically take the YAML that is, if you click on these tiles, it will give you the instructions. And for Captain, you would just add this to the Git repository. And you don't even have to upload it with Git push or something. You can just use the Captain CLI with Captain add resource, and you would add this file, and it will place it into the right folder for you, and then the next run will already pick it up. So this is how we integrated this.
Thank you very much.
Thanks.
Yeah, there are a couple other. I don't know if that something's going on my screen. Sorry. Yeah, we have another couple of questions from Daniel Gonzalez. The first one is, how is the integration of Captain with Grafana?
Yes, very good question. So with Grafana, we have not yet updated to the latest version of Captain. So I think the latest version of Captain was released I think it was last Friday. And we changed a little bit of the eventing there. So the integration with Grafana is actually that whenever you onboard a new service to Captain, not the service like a Litmus service or a Chemita service, but like really your microservice. So each time you add a new microservice to Captain for Captain to manage its delivery and its testing, the Grafana service will also react on these events. As said, everything is a cloud event in Captain, so you can listen for these events, and then the Grafana service can generate dashboards for you based on the SLI and SLO file. So here we are kind of closing the loop. We are reusing the files from the quality gates. We are also reusing this for the Grafana part. You will also find this in the Captain sandbox. This is all of our integrations that are kind of new. And we first go into the Captain sandbox, and once we see adoption, and once we also have Captain core contributors kind of picking up these integrations and getting involved in these integrations, we move it to the Captain contrib repository, and these are the ones that we kind of maintain from a Captain core maintainer perspective. But you will already find that the Grafana integration in Captain sandbox is just not yet upgraded to the latest version of Captain.
Okay, very well, very good. Yeah, thank you. The second, and this is, I guess, the last question we have for you is about extensibility, and also comes from Daniel Gonzalez. I would love to add K6 as a load testing chaos engineering extension. How does the process look like?
Yes, that's very nice. So the process is actually, it's always depending a little bit on how the different tools behave. But what we do have is a service template, a Captain service template. It's written in Go, and you can just use this template. It's on GitHub. You use this template, and it comes with a couple of different event handlers already. So a testing tool would actually pick the event handler test triggered. That would be the cloud event. And you just put all your business logic into this event handler. So the Locust integration and the Litmus integration, they are similar in the way that they just listen for test triggered events, sometimes also for test finished events if they have to do some cleanup work, for example, if they also want to get informed if other tests are finished. Then you basically put your business logic in this event handler. So for Go, we have this template. And then it's best to reach out to some Captain maintainer or in the Captain Slack to let us know, to also put this in the Captain sandbox to be available for others. If you want to add it to a Captain installation, it comes with all the deployment files already. You just have to do basically a string replacement with your image name. But then it's basically just adding this to your Kubernetes cluster, and it will then receive already the cloud events, the distributors. We're using nuts behind the scenes, and the distributors and how to retrieve these events. Everything is already there for you. You really just have to put in your business logic in this event handler. And there is a service template. I will also put it into the chat box if you're interested, Daniel, and I will put it there for you.
Yeah, thank you. That will be cool. Right, thank you very much. There are no other questions. So yeah, perhaps on the interest of time, we could say thanks to Jürgen and give the stage to Andrés.
There you are.
Thank you, Jürgen. Really nice, really interesting. And we are now jumping in my company into the whole chaos testing. So it's interesting to take into account. So we will definitely take a look. So I'm gonna share my screen. Then we can start. First thing, I'm gonna present myself. So I'm Andrés Torres García. I'm originally from Asturias, from Avilés. And then I've been traveling a little bit around. So I moved to Madrid. And then I moved to Netherlands. I was working in Amsterdam. And then I moved to UK. I was working in London. And now we are back to Asturias, back to square one. Different situation, of course. But well, for now, everything is going good. I was a little bit envy when you were all sharing maps. So like Jürgen and Marcos at the beginning. So I'm going to share maps also so you can see my traveling from Asturias to Madrid and then to Amsterdam again and then to London and then back. So that's the journey. I'm a software engineer. I studied in Asturias in the Gijón University, and then I moved to Madrid to work as a consultant in a product company, and then I moved to Netherlands to a fintech company called Backbase, which is the one we're gonna start talking today. And then with the same company, I moved to the London office, and now I'm working remotely, meaning that I'm in my pajamas most of the time, but well, working from home for the same company. And we've been through a journey. I've been in this company for 5 years and a half, and now we are facing the final steps of moving to the SaaS model. But we started this 5 years ago. So I'm gonna share a little bit about myself if you want to contact me later on. So this is my personal website, where you can find my LinkedIn and any other social networks. And if you want to check what I do or what we do also in the company on the open source, you can check my GitHub account, Torres Pro. So feel free to contact me here, also in the Twitter, etc. If you have any questions later on, or you want to know something else. So let's just start. So I'm gonna have a little bit of a disclaimer at the beginning. Here. So I'm going to be talking about our evolution of the last 5 years and the changes that we did in the company, the changes that we did moving from the on-premises deployments with 3 or 4 VARs to what we have today, which is more than 50 microservices in the cloud, in a Kubernetes cluster. And in some cases, we're going to mention things that went wrong or things that didn't work for us. But again, it's something that it didn't work for us. It doesn't mean that it's a wrong decision for everybody. So you need to adapt. And well, I was reading a book recently about the laws of software architecture. And I like the statement that we have there. Everything in software architecture is a trade-off. So it's not black and white. It's not like this is a good way to do it and this is the wrong way. Sometimes what it worked for me or for my company is not going to work for you, or vice versa. Maybe you tried some of the solutions that I'm going to talk today, and for you are all working perfectly. So we tend to think ourselves when we architecture something, we have that picture in our minds, maybe like the Matrix architect, but the reality is a little bit more like this. So our architecture, especially when it many years of many people touching it, it started to be a big ball of math, and it's difficult sometimes to understand when you jump in why we are here or why we have all these problems and all these issues. So I'm going to go step by step through our decisions and how that decisions affected the result and what changes we did later on to adapt to the market, to our customers, and to our own situation. But again, nothing is black and white. Nothing is perfect. If you adopt what we have now, maybe it's working for you. So I see also some colleagues from Backbase in the call, in the meeting. So it's good that you learn from our mistakes, but sometimes the situation is different depending on the context. So let's start for 5 years ago when I joined the Backbase. So there was the monolithic area, pre-microservices. The company at that time the focus was to be a presentation platform, providing banking features to the bank. So the majority of the effort was put in the front-end part. So we were creating widget collections. The technologies we use in the front-end was Angular back in time. And we didn't provide any data ourselves. We didn't provide any backend systems ourselves. We were doing integrations all the time in every single project with the bank. So we have this portal that we used to call the portal technologies. So it's where we put these widgets or this collection of front-end items, and we're creating websites for banks based on that. And the reality was that we were deploying 3 microservices, well, 3 services, not micro at the time, portal, content, and an orchestrator to move things between the other 2 services. And then we added a 4th one for the search. So the total of 4 services to do everything that we were doing back in time. And then in every single project, again, we were creating integrations with the different systems in the back, core banking system, databases, even sometimes file systems. Whatever they have in the banks to provide us data, we were integrating. And for that, we were using one integration software called Camel. I'm not you're familiar with it. It's similar to others like Mule or Spring integration. So we were using Camel back in time to integrate with everything in the bank and provide an API for our front-end platform. The technologies, we are a Java company, so we were using Java, we were using Spring, plain Spring, we were using Camel as mentioned, we were generating words, or well, in the project we were generating words, and we were deploying those in application servers. So we were supporting Tomcat and a couple of more, JBoss, and that's it. Well, we also had a database, a small database to support everything. So this is how it looks like when we were deploying in a customer. We were building websites back in time, not even mobile when I joined. We were only doing web or starting with the mobile part. So this portal, this publishing and this content services is something that we provided. And then in the projects, this is the custom part. So the security, we always need to build the security in every single project to connect to the bank security, and integration to get actual data to provide to our front end. So those tasks, even though they look small here, they were huge in the projects. So it was a lot of time invested in every single project to generate this part and to make it work for our front end. The problems with this, we started to see in the market that we were missing some features that other competitors were bringing because they had the data. They were providing some services with some data that they were able to create more front end based on that data. We were depending on whatever the bank has, and we were doing it in every single project. So also not much reusability, because every single project, they have a different core banking system, or maybe they have the same core banking system, but they put a layer on top of that, an ESB, or a set of SOAP microservices, and it was difficult to reuse stuff from one project to another. We had a lot of drifting, even inside of our project. We were using, of course, Java, Spring, and Camel, but then we were doing different things in different services. So the reusability, even internally, was not really something. So the effort was almost the same in every project. And then because we were giving all this freedom to the projects and to the customers to do the integrations and the security, it was really difficult to do upgrades of our software because you don't control what's built in every single project, right? So we will need to check in the project what they have and then analyze it and then be able to do the upgrade. So it was not an easy process. And sometimes because we were not in control, because the services were not black boxes, a lot of hacking was happening, and then the upgrades were directly breaking. So it was not only that it was difficult, it was impossible. And we will need to do almost re-architecture the whole project for the next version. So that was the situation 5 years ago. And then we started to think that we needed a change, we needed something extra. So a new group of architects joined, and with new ideas, and then we moved to the next part, which is the welcome microservices wall. So we did the first attempt of microservices because we wanted to have more capabilities and more features to give to the customers to convince them to sign the license with us. So for that, the first product that we introduced into the mix, apart from keeping the one that we just mentioned, the CXP, the portal, we introduced digital banking services, which is a middleware layer of microservices with more features, banking features, payments, accounts, transactions, etc., etc. But that layer was still not core banking, so that's why it's a middleware. So we still need to connect to the bank, and still we need to get data. But then the data was on our system already. Even if it's a middleware layer, it was living on our system. The technologies we choose, well, we can zoom it a little bit in the schema. So that's actually a screenshot for our Confluence. So it's the 1.0 architecture was designed like this, following some of the microservices principles. So we're having a gateway, single entry point into the system. We were using a registry for service discovery. And then we created this triangular architecture based on SecurIS and event sourcing. If you're not familiar with SecurIS and event sourcing, the idea is to divide the reads and the writes, because, well, sometimes you read more in the system than writing. So you use eventing for everything. So the communication is via a queue. In this case, we were using ActiveMQ at the beginning. And then we were saving all the data into a NoSQL store, and that the case was Elasticsearch. We still need to go to the third-party systems, as you can see. We still have these integration services, but the rest is provided by us, and we have this command store and event store when we support. So that's the template that every team needed to follow back in time. So we were sharing this with the teams and telling them, hey, if you're building a payments capability or an accounts capability or a transactions capability for the bank, you need to follow this architecture. You need to create microservices. They need to go to the registry. They need to be accessed via the gateway, etc. That came with some, oops. Let me go back here. So the first problem we face it with this is the Elasticsearch storage. So the first customer did an analysis to put the whole system into production and how much will be the cost to put the Elasticsearch and the rest of the system in high availability. And they got from different vendors 6 figures in budget that they needed to spend. And there was a lot of money for them. So we needed to change that to not make it mandatory, because in the first design that you just saw, it was mandatory to have Elasticsearch for the SecurIS and event sourcing. So we changed that and we use it the normal databases, normal RBDS. So we supported MySQL at the beginning, and now we support also Oracle and SQL Server. So we changed the projection and persistent service that you saw previously into this persistent service. So the idea is similar. You still have the SecurIS, event sourcing, etc., but you save it into this normal SQL data store. All the problems that we faced with this, it was expensive, as we mentioned, so the customer said no to this approach. Also, the SecurIS and event sourcing approach is not straightforward to understand, so you need to understand the paradigm and how it can be used. And we also maybe were guilty to a little bit of silver bullet effect. So we wanted the SecurIS solution for every single capability that we were building. Every single team needed to follow the triangular and needed to follow the approach with SecurIS and event sourcing. And maybe some of the things we were building doing SecurIS and event sourcing was an overkill. Looking now back, maybe some of the capabilities, like, I don't know, like your beneficiaries or your contacts, maybe a normal CRUD application will be enough. But well, it was mandatory for every single team to follow this. Together with the lack of knowledge and difficulty to understand from our customers, it didn't really fly. And we needed to change even before going live with the first customers. We made changes, so we removed Elasticsearch, and we were doing more changes when new customers joined. Another thing that we were trying to do at that time, it was to have a partnership with Cloud Foundry and deploy the whole system into the pivotal Cloud Foundry setup. So for the ones that are not familiar with Cloud Foundry, it was, well, it's for saying it's the loser into the containers orchestration wall, because even Pivotal moved to Kubernetes now with PKS. So it was a containers orchestration tool, still using not Docker containers, but what they call the Diego containers, quite similar, even was possible to run with Docker. And it was tried to make this orchestration really easy for developers. The good thing for Cloud Foundry is that you, from your terminal, you only need to push your code, and it's going to be packaged using the building packs that now we are all familiar with it, because Spring and the rest of the vendors are moving towards the build packs. But back in time, I think this was the only system using it. And then everything was packed, creating this container and being deployed in Cloud Foundry. Cloud Foundry was also using the same approach with gateways and service registry. So it was matching our stack that was based on the Netflix stack. So some years back, Netflix, one of the first companies adopting the microservices at a huge scale. And they were creating tools to be able to manage all this. They created a Zool, that was one piece of software to acting as a gateway. They created Eureka as the service registry. They created more tools just to manage all these microservices. But keep in mind that was all before Kubernetes exploded and Docker containers and containers exploded. So Netflix was using all this stack to deploy in Amazon, in AWS, in normal EC2 machines that were scaling up and down when needed, but we were not talking about containers back in time or Kubernetes or nothing. It was normal machines being spawned when they needed more traffic. So they created all these tools to be able to manage all that. And we adopted that stack together with what we mentioned, SecurIS and event sourcing. Good things back in time, if you look now from this 5 years perspective, it was the latest of the latest, actually. So it was fancy as a developer to play with all these tools. It was fast at the level of when you have everything deployed, the execution was fast. And give us some things like historical state. The good thing with SecurIS is that you can replay the system as far as you want. So today, these are your events and this is the latest state, but you can go back 3 or 4 steps and you have the same state that you have in the system 3 times back. That was good for the product that we were trying to sell for banks, so they can reproduce problems or how the system was 3, 4, or 1 week or 2 weeks back. So that was the good thing from SecurIS and event sourcing. But again, we have all these problems. It was expensive, difficult to understand, and it didn't fly. So we started to make changes to adapt to our own ecosystem and to adapt to the customer's ecosystem to make our developers easier their lives and their day-to-day. So we move to the next step, which is the attempt to on microservices part 2. So we tried to learn from our mistakes and we analyze the problems, and with the feedback from customers and from our own teams, we did some steps towards the technologies or the stack that we have now. So the triangular architecture that you saw in the previous slide is presentation service, persistence or projection service, and the integration service. It started to become, well, it became an anti-pattern. Actually, if you check, we're going to cover now that is one of the microservices anti-patterns, to divide by layers. So we inherit that triangular architecture, even though we dropped event sourcing and SecurIS. So we dropped that technology in favor of REST CRUD applications. So, but we still had this triangular and these 3 services communicating between each other. We moved the stack a little bit more closer to the cloud. So Docker, Spring Boot, Spring Cloud, etc. Those started to be used internally. We moved some of the legacy systems also from Spring to Spring Boot. So we were aligning the whole stack, so everybody was following the same. And we were trying to get more stability. Like at least the legacy systems were moving to Spring Boot and Spring Cloud. The previous services that we created for SecurIS and event sourcing were on that technologies already. We were on progress with the drop of event sourcing and SecurIS, so we were aligning everybody into the same technology, into the same stack, and also at that time Netflix stack was also disappearing in favor of Spring Cloud Netflix, that at the end is even what Netflix recommends nowadays. So the stack moved to something like this. So we still have the gateway as the entry point in the system. We have the registry based still on Eureka. We have the microservices for the portal, the part that you saw at the beginning, but also the microservices for this middleware layer called DBS. And we still need to do the integrations with the bank. So this was the setup, and DBS could be multiple. In this case, because of the triangular architecture and the number of capabilities that we had, it was each capability 3 services or more. So we end up with more than 60 or 70 microservices running to provide the functionality that we wanted to our customers. So we reached to a point when everything was more stable, everything was more aligned, everybody was using the same technologies. We were getting closer to the stack that the cloud vendors and everybody was deploying in the cloud, because we started using containers. But we were all not fully on Kubernetes, and also not fully on deploying in the cloud. We were still deploying in our own services internally to test, etc. So at the level of anti-patterns that we were following at that time, and we fixed, the most important one was this triangular architecture. So this was the setup for every single banking capability that we were providing. So the payments capability it was divided into presentation service, integration, inbound and outbound, and persistence. The accounts capability, another 3. The transactions capability, another 3, etc., etc. So every capability will have like 10, 12 capabilities multiplied by 3 times or sometimes more, because we had some capabilities with more orchestration included. So these inbound integrations, meaning that the bank was calling us, and the outbound meaning that we go to the bank or the third-party system, get the data, and come back. So that setup, again, when we move away from secret agents and event sourcing, was directly an anti-pattern. So if you check the list of microservice anti-pattern, there is one, the layer architecture, when you find that dividing into business functions, so one for orchestration, one for data access, one for business logic, is detected as an anti-pattern. And what is recommended is a component has a business function and they should do everything they need to do, from storing in the database to orchestrate any of the calls, etc. So looking at this and acknowledging that it was a pain for our customer to deploy that many services without really any benefit, we decided to move to what we call the lean architecture. So we were collapsing these 3 services into one. So the persistence, the presentation service, the first one that you access, and the inbound integrations were all into one service. And then we keep as a separate thing that we normally do in projects, these integrations to go to the third-party systems and get data. Because again, we are not a bank yet, so we still need to get the data from the banks to put it in our middleware layer. We started also with the mobile wall together with the web. So we were making some progress and making our architecture leaner without losing any functionality, which is the key. Because reducing the 3 services to 1, we were not really losing any functionality and the customer eyes. So the next step was actually a little bit faster than we expected, and it was because of the customers. They adopted the cloud faster than we expected, and we needed to adapt to that also. So it was the cloud time. So even internally, we were not fully on the cloud, and we had multiple customers deploying the projects into the cloud, most of them in Kubernetes, some of them into Cloud Foundry, but most of them were adopting Kubernetes in any of the flavors. So vanilla Kubernetes, but in most cases, something like coming from a vendor, OpenShift, AKS, etc. Azure, well, all the vendors were coming up with their own Kubernetes approach. So depending on the vendors that our customers were using, they were adopting one or the other. But well, we tried to keep it vanilla. We try to keep it working with any Kubernetes setup. At the end, our applications are Spring, Spring Boot, and Dockerized, so they should work in any Kubernetes orchestration system. But again, that was happening on the customer side before happening internally. So we were not testing on Kubernetes cluster the whole system. We were still testing on EC2 images in the cloud, in AWS, but not in a cluster with Docker images. So we started to speed up that process. We started to generate our own Docker images, started to have our own Kubernetes clusters to test the whole system. We started to use Helm charts for the deployments, and we started with some GitOps internally to be able to test the whole product. The good thing is we were able to do all these adoptions because our architecture was easier to move. It was not the same to move the triangular architecture to Docker than moving 3 times less with the same functionality, which is, again, a really important point. We added more automation, we added a better CDCI, and it was a better alignment with customers and projects because they were deploying in the cloud and we were deploying in the cloud using Docker and using Kubernetes. Because at the beginning, most of our projects were going that way, but we internally, we were not doing all that. So they have questions about how do we do this and that we were not able to solve because we were not testing in the cluster or in Kubernetes like they were doing. But we faced some problems also there. So there was a learning curve to know all these new technologies. Kubernetes is complex, how to do Docker properly, etc. And then we had the problems of setting up the customers during what we call Sprint Zero. So when we put the system in place, when we prepare environments for dev, testing, pre-production, production. And then, so at the beginning of the projects, mostly because we didn't have the experience of how to do it properly. And then the day 2 operations when you go live. So after going live in a complex system like a Kubernetes cluster, if something goes wrong, how are you going to troubleshoot this? We were not experts on that because we were not doing it ourselves. So that was the problem. And then techniques like Jürgen was showing, couch testing, etc., they were not part of our day-to-day testing. We were still testing in the all non-cloud, non-containers world. So this is a small example of a small piece of the system that we have nowadays available to deploy in a Kubernetes cluster. So we have our own Helm charts, and we use it to deploy our own Docker images. And then this is, again, it's a small piece of it. So we still have the gateway. In Kubernetes, we don't use Eureka anymore because Kubernetes comes with their own service discovery. So Eureka was redundant. So we are not using that. We delegate to Kubernetes via Spring Cloud Kubernetes. So our services for them is transparent using one thing or the other. And then, well, we have, again, a small subset of our services, but you see that everything is deployed and everything is orchestrated via Kubernetes cluster. So we were getting closer to what the customers were expecting from us and how the way they were deploying, but we still saw some problems at the level of knowledge internally and also in some of our customers, because they wanted to use the latest of the latest. They wanted to use Kubernetes because it's fancy, because they read it on Reddit or in the internet, and they wanted to be with the cool guys. But then the knowledge that you need to manage a system like that, especially in a production financial system, is really a lot, and most of our customers were not ready. So what was the next step for now for us? Moving to a model that we manage not only the software part, but also the deployment, because we saw our customers struggling with this. So in the meanwhile, I want to do a small demo. So I'm gonna execute it because it takes a while. So I'm gonna execute it now. And let's see if everything works. This was not prepared, but I was, again, I was envy from Jürgen demoing cool stuff, and I was only showing the slides. So I'm gonna try to install the Helm chart that you saw, the diagram that you saw. I'm gonna try to deploy it in a local cluster, only a small subset of services. So I'm gonna hit it from here, and then let's see how that goes in a couple of minutes when we finish the presentation. Let's see if it's starting well. And then we move. Yeah, let's leave it there for a while and see if everything goes okay. And now back to the presentation. We wanted to move to a model where we could support our customers not only with the software that we were providing them, all the features, but also helping them with what they were struggling, the Kubernetes part, the deployment part, and the operations when they are in production. So moving to the next is the SaaS model. So we were, you know, probably this idiom about eating your own dog food. We modified that a little bit, and we're talking about drinking our own champagne, because it's a little bit more classy. But at the end, we wanted to do what we were telling the customers to do themselves. Like, okay, we give you this software, now you need to deploy it yourself. And they were struggling for multiple reasons. They didn't have the knowledge, they didn't have the people, etc. So we started to do it ourselves, and we saw there was a potential market opportunity to move to that model and remove that load from our customers, that burden, and we just also have something else to sell, which is always a good thing, right? So the technologies are similar to what we just saw from the cloud, so Docker, Helm charts, everything cloud related, but now it's owned by us and not telling the customer to deploy. And then on top of that, of course, because you are managing your own cluster, you need to be able to troubleshoot, to analyze the problems, etc. We have some tools for observability, etc. But well, new things that we introduced recently was the service mesh. So we are using Istio for that. We are deploying everything in AWS AKS. We have Terraform for the whole deployment CI process. We are moving towards the multi-tenancy. So the idea is to have under the same cluster more than one customer or more than one project. So we can reuse the hardware to support multiple customers. we are using more and more GitHub Actions. We were really heavy dependent on Jenkins in the past, but we are moving towards GitHub and GitHub Actions a lot. We are using Datadog for observability and for the log analysis, etc., monitoring. And then other things that you need to take care that we were not taking care before is what do you do when you have disaster recovery? How is your response time, etc., etc. The good things from this approach are that we build it, we deploy it. So you learn a lot from deploying your own system. And I was, before joining the R&D part of my company, I was doing projects myself and taking the customers to production. And we knew all kind of problems that we used to have. And now we are facing those problems directly in R&D because we need to deploy our own system in the SaaS model. So that was good because there are a lot of learning opportunities and learning lessons. Another good thing is we go faster in this Spring Zero parts that we mentioned before. So putting together the whole system and to deploy it like I'm doing it now behind the scenes is taking way less than it used to be because now we do it and now we provide most of the tooling to our customers, even if they want to do it on their own. But when we do it ourselves, it's a matter of hours to set up the whole system and different environments. But also it comes with some problems or maybe challenges, if you want to call it, because you have extra responsibility when you host banking data, like we're going to start doing or we are doing already. So you need to have banking level security. We had to pass some certifications to be able to actually do it. We have some restrictions depending on the customer. If it's a customer from US, the data need to stay in US. You need to have a zone to put all the data there. Things like that we were not aware before because they were owning the whole deployment. We were only software company shipping that for them. Now we need to face and to analyze and to have responses for that. Uptime of 3 nines. So all these things are challenges that we were solving, and we are now able to solve in the system we have. So just a small, I'm not going to go into everything that we have in our SaaS model, but well, it's heavily relying on AWS, as we mentioned. So we have the databases, we use Amazon Aurora, the MySQL version. We use Amazon InQ. We use AKS, as we mentioned. We have the load balancers, the Shield, a lot of tooling from AWS, the container registry, everything from AWS. But again, we are still not a bank, so we still need to connect to external systems to bring data to our system in the cloud. So we need to have this connectivity to external systems via direct or IPsec side to side, or we use multi-TLS. Well, we use different approaches depending on the customer possibilities. We have set up the whole monitoring with Datadog, PagerDuty, as we mentioned. And then we have specific teams helping the customers to build the custom part, because again, we have a lot of banking functionalities. We have the security system also based on Keycloak. We have more products than ever. We have now 5 lines of product. 5 years ago, we had 1, as I mentioned. But we still need to connect and we still need to work with our customers. So we have these teams directly dedicated to help every single customer to go live with our SaaS model. And now that we are in the SaaS area, we are thinking what are the next steps, because we still have customers on the on-prem side. So we have plenty of customers still not in the cloud or not ready to be in the cloud. So we need to transition in these next 2 years, 2-3 years, all these customers to the cloud model, to the SaaS model that we have. So we need to prepare, upgrade paths for them. We need to analyze every single product and project to see how we can move them and help them to move to the cloud, etc., etc. So that's where we are now. We are almost there, but we still need to move the whole ecosystem of customers to the SaaS model, convince them that's the way to go, and show them all the benefits, etc. I want to show also one extra. It's not part of the slides, but I think you will appreciate. I mean, we have a lot of microservices, but we don't have, as I don't know, for example, a bank in UK called Monzo those guys have more than 1,000 microservices. So it's really a different approach. For us, I think when we put everything, all the products we have, plus the customers, we are talking about 50, 60 microservices. But I would like to show you the ones that we have in a diagram. It's not going to be easy to see everything, but at least you can see a helicopter view of it. I'm gonna log in into our internal documentation so you can see a bit of it. In the meanwhile, I'm going to see if the system that we were deploying is up. So we can see that all the services that I'm deploying, again, is a subset of our services are deployed. So I'm going to try to log in into the system. I still have one of the services. The job that is actually putting all the front end is still finishing, so not fully ready yet. So when this service finishes, we will be able to log in into the portal, into the system. Again, it's a subset of the services we have, but it's interesting to see how we can run with one single command the whole system in a local setup, but it's still interesting. So I'm going to show you now what we mentioned about the whole system in a C4 model. I don't know if you're familiar with the C4 model, but well, it allows you to zoom into the different components in the system. Again, it's too many services, too many lines and arrows, so it's going to be confusing. But just to give you an idea of the amount of services that we have, comparing with the 3 that I showed you at the beginning of the trip 5 years ago. This is the whole setup we have now. We can zoom in maybe in a little bit of one part of the system. So we have all these banking capabilities. You can see transactions, financial insights, contacts, etc. You can see all the interdependencies with the services, which is one of also the problems that we faced at the beginning. We were kind of a distributed monolith instead of a microservice. We have dependencies, so the whole system needed to be deployed together. But well, you can see this is just part of the system, not the whole system. You also need to deploy some custom services, but you can see the complexity compared with the 3 at the beginning. Well, this is the microservices wall, and that's what we have now. And we're going to keep adding and adding services and functionality because we saw what our customers are requiring, right? We need to keep selling, so we need more functionality. And basically, that's the journey from 3 services, monolithic, that we were deploying at the beginning with almost no real backend capabilities, mostly front-end, to the whole system that we have now that we deployed in the cloud with all the microservices you just saw. And the lessons learned in the meanwhile, also the company moved from 200 people to more than 1,000 that we are now. So apart from technology challenges, we also had the typical growing pains of a company that was moving from small to medium big. So all that contributed to this journey. It was really challenging, but well, I also grew together with my colleagues with the company, and we are happy to see where we are going now with this full SaaS model and what is expected. So that's actually it. I don't know if we have any questions we can go through or comments, but that's the journey. That's the journey I wanted to share with all of you, to see that maybe you have some lessons that you can use in your own challenges in your own companies.
Andrés, I'm pretty sure many people in the audience and the ones that will follow offline, they will see this with a huge value, I can tell you. A lot of lessons learned here. So, Angel, I don't know, maybe we can go through the questions?
Yeah, there are a bunch of questions that we can go through. The first one comes from Alberto Carrasco. Not sure if I missed it, but what database did you put in place instead of the Elasticsearch when you decided to discard this option?
Yeah, so we again, because we were not fully SaaS back in time, we needed to adapt to. That's also one of the problems that we're gonna solve by moving to SaaS. We're gonna be more opinionated about the stack that we're gonna have. In the past, the customer is always right? So if the guys have Oracle, we were adopting to Oracle. We tried to keep it small. We started with MySQL because the first customer was supposed to be one with MySQL, but then the second customer was already using, you know that the banks normally go with the big vendors. So usual suspects, Oracle, Microsoft. So we support those three for now. We support MySQL, Oracle, and Microsoft SQL Server. The first one was MySQL, but then really quick we adopted the other two. So we use Liquibase to generate multiple scripts, so we can we don't need to maintain them manually. So we generate the scripts for the three databases we support.
Very interesting. Thanks. There is another one also from Alberto. Do you still develop new features for the old customized systems, or you simply maintain them and encourage your customers to move into the cloud?
A little bit of mix. So officially, everything that is new is going to the new setup and to the new stack. But we have big customers that are still in the old versions that are maybe about to be out of support or not supported directly. But again, customer is always right, and if they paid enough, we are kindly moving some of the features to them. But most of the customers that are not in the cloud are planning to move themselves to the cloud. So they are adopting Kubernetes themselves on OpenShift or in AWS themselves. And for the others, again, we are preparing these plans, custom plans, to move them to this SaaS model, sometimes with, more features, sometimes money, sometimes discounts, sometimes offering services for free. Our colleagues from CS, so our professional services, are now really busy, and the coming years are going to be really busy for them to help all these customers. But the idea in general is to everything that we put new is only for the new versions, so even only for the SaaS model, for example. We are now trying to invest into some things based on marketing campaigns, etc., that we're going to release it only to the SaaS model for now, because we have all the data there and it's really easy to do. But on the customer side, we don't know if they have the data, so we're going to focus on the SaaS. But sometimes you need to be flexible with the customers to keep them happy.
Yeah. As a follow-up question for myself, are they banks or are they intermediaries? Your clients, I mean.
Mostly banks. Yeah.
Mostly
we have some insurance companies, and we have some cases in US and in Canada especially, that they work with these banks that are really small, what they call credit unions there. So they are really banks of engineers or banks of farmers, like that. Everybody is putting. So it's like everybody puts money into the bank. So
it's like a fund. Yeah.
So it's like 300 clients or 3,000. Yeah. So for those banks, sometimes they have a vendor that is providing software for all these different credit unions, and then we do the deal with those guys. So we sell the software to those guys, and then they prepare the same setup for multiple customers. But if not, we talk to the big guys, tier 1, tier 2 banks directly.
Yeah. Okay. Understood. Thank you. There is another question from Daniel Gonzalez. Thanks for the talk, Andrés. Out of curiosity, for the observability part, I understood that you are using Datadog for metrics and log collection. Are you using distributed tracing too? If not, do you have plans to adopt it?
Yeah, we have. So I don't know. Maybe I skip it in the second part when we were talking about the adoption of the microservices. When we said the technologies stack, the Netflix, etc., we provided a service SDK for our teams. So we had a team dedicated to create a group of libraries or templates to create microservices, everybody in the same way. So we were using Netflix stack, and then we moved that to the Spring Cloud because it was the natural step from Netflix. But we had libraries for tracing, we had libraries for the login aggregation, etc. And for tracing, we use nowadays Sleuth, which is coming from Spring Cloud also. We use Spring Cloud Sleuth, and then We can use Datadog to show it. We can also deploy Jagger, or you can deploy Zipkin to actually visualize the whole tracing. But yeah, it's part of the system.
Okay, very good. Thank you very much. And there is one last, I would say, comment question coming from Anatoly Volkodab. We can't see front end, so I don't know exactly how to take that, but maybe
was during the demo, Andrés was typing out of the share screen, but after that he came back with the screen. So that was, I think.
I think it was resolved. So yeah, I'll take that one.
The front end finish here. So it was this. I was trying to to log in to see but I was trying to log in our internal system, so I didn't want to share the password with all of you. That's why I was typing there. But then this is our, well, one of our front ends based on what we just deployed. So you see this, it finished. So we have a website, a portal when we can log in now with the demo data, and we should be able to log in the system. So what you see now is not what the final customer see. This is for the admin. So you can see the experiences that we call. So you can see the websites, and you can modify, add pages, etc. The customers, what they see is the final banking website with all our front-end capabilities. The login is based on our new product, based on Keycloak. So we are extending Keycloak with more functionality, because we also saw a gap in the market for that. Well, that was basically the journey. Again, from one product, 3 services, to 5 lines of product that we have now, and more than 60 microservices, all deployed in the cloud on our own cloud. It was, now that we put it all together back these 5 years, it was an amazing trip. We grew a lot. We had a lot of problems also with the number of people. The learning curve was not easy. So when I joined the company, we were in the professional services. I think we were 12 backend engineers. Now, between the guys in professional services plus the people in R&D, only backenders, because I'm now acting as director of backend in R&D. We are more than 150, I think, and growing, because we keep hiring. This year, we are planning to grow in every single area: backend, frontend, mobile, DevOps, system engineers. So it's been an amazing journey, and let's see what the future brings with the whole SaaS. But well, a lot of lessons. As a professional, you like these kind of challenges because you make you better, right?
This is what we are here for, right?
Yes.
All right, thank you very much. Very, very interesting journey. I appreciate your talk and the insights you come across. So I think this is very, very valuable for our audience, and also for ourselves. So yeah, congratulations, and thank you very much.
Yep, thank you guys for helping me and allowing me to share.
Anytime, Andrés, anytime. Cool. So just to finish the event, I will just very quick share my screen. So there we are. This is it. This is it, people. Thank you very much for coming along. You have, as usual, a survey. Please be my guest. Is helping us to improve. Actually, some of the differences that we put in place today was thanks to that feedback that we get doing the survey. So again, thank you very much. Last but not least, I wanted to share with you all, guys, that once we finish the event here, we will jump into the Twitch channel to make like a post-event talk, very, very informal. Today, Andrés will join us. Will join Angel and myself. So just in case you want to pass by, because we will talk about how the event went, insights, feelings, this kind of stuff. So feel free to pass by. Angel, something to say?
No, just like thanks everybody for coming along, and thank you, Andrés, and thank you, Jürgen. I'll hope to see you guys soon. Thank you very much.
Thank you, everybody, and see you soon.
Bye. Bye.